and directing research and product development in mobile and vehicular networks. He holds over 30 patents and has co-authored 2 books: Vehicular Safety, Communications, Protocols, Security, and Privacy, and IP-based Next Generation Wireless Networks, published in 2012 and 2004 respectively by John Wiley & Sons. Dr. Zhang was a founding member of the Board of Directors of the Connected Vehicle Trade Association, CVTA, in the U.S. He is the chair of the IEEE Communications Society Technical Subcommittee on Vehicular Networks and Telematics Applications. He's been serving as an editor for several technical journals, on the industry advisory boards for several research organizations, and as an adjunct professor at multiple universities. And with great honor, I'd like to introduce Dr. Zhang.
Thank you. Good afternoon. This is Hao Zhang. It's really my honor and a pleasure to be here and to share with everyone some of the issues that my colleagues and I have been trying to address in Cisco for securing connected vehicles and also for securing the Internet of Things in a more general sense. So but today I'll focus on the security of vehicles. So I'll start by talking about some of the vulnerabilities, and then I'll talk very briefly about what people have been doing in securing the vehicles today and what are the limitations. And then we'll examine the question, can we just use the existing mountain of technologies in the crypto and security area to solve some of those problems or to fill some of those gaps? And if not, what are the problems? What are the issues that are still remaining? And then I'll describe very briefly and the framework under which we are working, trying to address those issues. And I'll use one example to dive a little more detail to show, just to illustrate some of the deeper issues that we have to address in this area to properly secure a connected vehicle. So that example would be malware defense. And so that's a very important, we think that's going to be one of the major areas of security vulnerabilities in connected vehicles. And I promise you I will not talk about viruses because it doesn't seem to be so nice to be talking about viruses when people are eating lunch. So I'm going to talk about malware instead. Look at a car and a lot of applications in the cloud. And so we first examine what are the major areas of vulnerability. Imagine this car needs to talk to the cloud. Imagine this car needs to talk to other cars sometime down the road. Okay. So the very first area of vulnerability is the devices and the networks inside the car. There are some cars have over 100 devices, electronic devices in the car, over 100 million lines of code, and some cars even have more. And those networks, those devices are networked, and a lot of critical applications are running, and you need to properly secure them. And today, for example, those networks are not very secure, and people have done a range of things. And we have seen an increasing number of articles revealing the problems. For example, people have successfully read memories of those ECUs in the cars and reverse engineered their security keys. People have been able to easily send messages into those cars with physical access to the car. People have been able to reverse engineer the communication messages that automakers try to keep secret. People have been able to use their own tools to update firmware. People have been able to also compromise the short-range radios and that cars have been equipped with. Another area of vulnerability is the onboard diagnostic interfaces. And those diagnostic interfaces, as you all know, are on every single car in the United States and in many other countries. They're routinely used for people to diagnose the cars, to update firmware on the ECUs. And not only people can do that with physical access to the interface, and those interfaces are now being connected wirelessly. A lot of dongles are commercially available for you to use to remotely access. So that has profound impact on how you secure the vehicles. And then more and more cars are now allow you to talk to the cloud, and the applications are increasing as we speak. And this may come in the form of embedded cellular systems in the car. This may come in the form of tethered cell phones. And also communication with roadside networks are coming also. Another area of vulnerability is the short-range radios that people are putting into their vehicles. Those include, for example, the phone tethering and onboard Wi-Fi for the vehicles to talk to the roadside, and onboard Wi-Fi hotspots for people to use to access the vehicles, to access applications on the vehicles, to access the internal networks of the vehicles. Last but not least, and the vehicles will be one day talking to other vehicles, and that opens up another very large area of security vulnerabilities. Through every single communication channel, malware could come into the vehicle. And the more channels you have, the more likely you're going to attract malware. And so that's going to be another major area that we have to be dealing with. I'll talk about it a little bit. So now comes the question, what have been done already and why are they not sufficient? If you look at the first method that has been used even today and that has been used for years is physical network separation. People try to put different devices on different networks and try to physically separate them. But that, as you can see, are becoming less and less effective because a lot of those devices on different networks today now need to communicate with each other. Yeah. So the next thing is, many car makers are using proprietary messages. And so those proprietary messages, as you can say, won't stay proprietary or secret for too long. And if you go on Google, you check, every time there is a new model release, the messages will be broken very, very quickly. Limited and hard-coded messages. A lot of cars today have the gateways and some ECUs accept only very limited predefined messages. And those messages sometimes are even hard-coded in the firmware, so that no other things will pass through the gateway, no other things will be accepted by an ECU, for example. And that has been effective in protecting the cars from security attacks. But however, as you can see, that is effective only when you communicate through a very small and well-defined set of messages. That's good for control purposes, but you cannot apply that to protect, for example, the internet connectivity, because all different types of data would come through those connections. You can't predefine them. And of course, people have been applying application and network-specific security measures, and those are very network and application-specific. Typically, they cannot be general enough to protect the entire vehicle. And people are also limiting what applications you can put into the vehicle and what applications can or cannot do on the vehicle. And a prime example is a web browser. And you see very few web browsers are being embedded in vehicles. One of the major reasons is that it's very hard to secure it. And you see web browsers on some limited vehicles, but to find functionality of those web browsers are strictly limited. And for example, you cannot be downloading anything. Firewalls and VPNs are gradually introduced into vehicles to protect vehicle-to-cloud communications. But one of the major issues that has been discovered is those VPNs and firewalls, as they are being defined and developed and used for many other domains like the enterprise, they are not designed for the type of scalability of the vehicles. Why I'm saying that? Imagine what they're designed for. VPNs as an example. VPNs are designed primarily for people who are outside their enterprise networks. What's the largest enterprise in the world? The largest enterprise in the world may have several hundred thousand employees. At any given time, a very small portion of them are outside their firewalls, are using VPNs. And now consider vehicles. And large car maker in the US, for example, are generating a couple of million new cars in the US and having tens of millions of cars on the road at any given time. Even a small portion of them are using VPNs. You're talking about significantly more than a typical enterprise network. And then we dive deeper into, okay, so how are we going to support all these millions of simultaneous connections? There are ways to solve it. We're looking into it, but we're not going to dive deeper into that area in this talk, just to bring to your attention. Then the next question is, okay, and you recognize why people are not using. So the message here are just a small portion of what people have developed in the crypto world, in the security world, in the protocol world, right? So then the natural question is, why can't we just pull in all these additional crypto technologies, security technologies, and protocols into the vehicles and call it job done? And turned out the task is not that simple. And a lot of the issues that you need to address has to do with the uniqueness of a connected vehicle that is so unique that those issues have not been well addressed elsewhere in the network domain yet. So I'll go through some of that just to illustrate some of those issues. So the number one thing is, and whatever you put on a car has very limited resources, and everybody recognizes that. But that is not the worst of the problem. The worst of the problem is that limited resources is very hard to change once you put it on it. It has to remain sufficient to protect your car for a long, long time. How long? 10, 15 years. That has never been done. Imagine that. How long does your antivirus remain valid on your computer? Yeah. Right. How long anything remains valid on your computer those days? So then the question is, okay, so what do I need to do in order to protect my vehicle when I have to put something on the vehicle and I don't want it to be too much so that it's constant? I want it to be minimum resources, and I can't easily change it. You can't be routinely sending updates to the car and let the people stick memory sticks into it and updating things, right? You can't be routinely updating the memory, the CPU. You can't do that. So then, what do you need to do? How do you solve that question? So okay, so that the problem doesn't stop there. Number two, you have a long lifespan. You have to keep your security functions up to date over this long lifespan. Yes? One thing in the security domain that's for sure, there's not so many things that are sure. One thing that you can be sure is that whatever you know, however smart you are, whatever you know about the threat, whatever method you can come up today is going to be obsolete a few years down the road. You can be guaranteed of that. Okay? So, that has profound implications on what you do for securing your car. And another thing is, to detect threats, you need information. Threats to cars may be only known by the cars. So you need to collect information from those cars. What does that mean? Today, for example, to secure your enterprise, routers routinely connect information from other routers and send them to a central place, and then they're going to analyze it, right? So in this case, you need to know what's going on in the cars. You need the cars to be sending information to you. And the major problem of that is cars, many of them, cannot be trusted. Your routers can be trusted so much more than a car. People with physical access to the car, as I said, can do so many things. When you physically have access to a car, you can easily get this car to send bogus messages without even compromising the security system on the car. You can do that by tweaking the input to the communication device. What does that mean? That means a car can be easily used to send bogus messages using valid security credentials. What do you call attacks using valid credentials? Insider attacks. 99% or most of the security methodologies and protections we develop today are not for insider attacks. They are for outsider attacks. They are for protecting your enterprise, right? This is your enterprise, you draw a firewall, you believe, you trust the people in the firewall, you only protect against people outside trying to penetrate into the firewall, right? So in this case, you got to think twice. Okay, and security operations, you can't be causing a whole lot of trouble to the users also. Today, if you have a problem, if you need to reconfigure something, if you need to update something, if you have a malware getting on your laptop, you want to get rid of it, you send your laptop to some IT experts, right? They give you another one, and they work on it properly, right? And you can't be doing that too often to cars. So what that means, whatever you come up with for cars, better be very automated, very lightweight, and cause zero or very negligible impact to the owners of the cars. And that, again, have direct impact on how you do things. And the next thing is, you have to consider all the spare parts. Why do you have to consider all the spare parts? It's not just the millions of tens of millions of vehicles anymore. Today, for example, and in order to secure vehicle devices, people routinely put the same set of things, security keys, for example, on all the spare parts. Why? Because you never know which spare part gets on which vehicle. And you hope when it gets on an arbitrary vehicle, it actually works, right? So when they have all the same credentials, it makes it easy. That's okay, but that will not satisfy one thing you really want to do. For example, we say, if somebody compromises something, like a device in a car or in a car, you don't want that to make it so much easier for the guy to compromise another car, right? Today, for example, people compromise cars typically have to have physical access to the car. So configuring all the spare parts with the same security credentials is not a big deal, right? Because the fact that I can compromise this car, and in order for me to compromise another car, I have to go there physically, so it's a lot of hassle. But that becomes such a bigger deal when you can compromise a car remotely. If I can compromise a car remotely, and I figure out how to compromise that device and that car, and if all the other spare parts are using all the other parts on the other vehicles on the same type of devices, use the same credentials, all of a sudden I can compromise everything. And that doesn't sound very secure, and that sounds like trouble. You got to figure something out. What does that mean? That means that the way you support key management, the way you support credential management may have to be improved. And it also means the system for supporting that all of a sudden has significantly higher scalability requirement that went way beyond the largest, for example, public key infrastructure operator you know today. And the interesting thing is, when the scale of things jumps to a certain level, you can't support it just by adding machines or adding people. You may have to rethink the architectures, for example. And highly scalable, I talked about that. So those are just a set of uniqueness. What does that mean? That means several things. That means, first of all, you can't just expect to pull in all the best and great crypto and security methodologies and solve your problem just by applying that trivially. And it also shows that it's going to be very hard, or close to impractical, I would say, for each car to protect itself individually. I'll show that with more data later on. So then the question is, okay, so what does it take? What is needed to actually properly secure this car that's connected? And again, talking about a car who needs to talk to the clouds of different types, and who needs to talk to local devices, and who needs to talk to other cars one day, right? What security services are needed to properly secure this connected car? Very first thing, you need to increase and enhance the in-vehicle security. And that's one of the things we have been developing. There's in itself a large area. For example, you can change all the cars, the internal inner workings of the cars overnight, right? And a lot of legacy networks are going to continue, and you're still going to be faced with a lot of very little ECUs that doesn't do much. You can't rely, you can't depend on them to implement crypto or advanced crypto or any crypto methods in some cases. And what should you be doing? And another thing is, you need to be better protect the access into the cars. And both from outside, remote, local, and other cars. And you need to be able to protect against denial of services. Denial of services to a car is very easy. If you're communicating, I know your IP address. I can just send a whole bunch of messages to your IP address and flag you. And also, if I got a virus onto your in-vehicle infotainment system, that usually tends to be the least protected area of your connected car. I can use that as my base to flood into the rest of your car easily. We actually did it. And so, and of course, you need to be protecting against viruses that are trying to get into your car. And you can be assured that people will try to send viruses into your car, because people have tried to put viruses on every single connected device, type of device that has been out there. So, and you have to secure the communications, of course. And one of the requirements for securing the communications is high scalability. We talked about some of that earlier, I will not repeat. So, we realized that a lot of the processing for protecting the car will not make sense or feasible be put on the car. You cannot rely on the car itself to fully protect itself in a consistent manner over the long lifespan of this car. So what we're thinking is you ought to be moving a lot of those heavy processing into the security, into a cloud. I'll call it a security cloud. And also a lot of the security processing, especially malware detection, requires a lot of information that an individual car will be hard to find. So you want those type of processing to be put away into the cloud. And then you can use that to do a few things to help you protect the car. First, there will be traffic that are going to go through the security cloud into your car. Or you can actually direct a lot of traffic to go through that cloud very easily. So you can protect your car from any attack that goes through those traffic. And the services provided by that cloud can then help or assist the vehicles. Assist in many different ways. Assist, for example, in keeping the vehicle up to date. Assist, for example, in detecting new malware. Assist, for example, in screening suspicious files. Many different ways. The challenge, however, is you have to come up with a way to do all of that in a very scalable and resources efficient manner. You can't expect this car is connected to the internet through high-speed connections all the time, right? Most of the time it may be connected through a cellular system. You cannot be abusing that connection because it's still costly. When it is parked or when it has some high-speed connectivity like Wi-Fi, and you cannot rely on that all the time from all the cars also. You cannot be just sending a lot of information constantly also because that's going to drain the battery. So you have to be very, very careful. And so that is something we have been working on. We developed very, very lightweight, very with procedures and protocols for that interaction. I'll talk about one specific case for supporting malware detection and malware processing right after. To make all of that happen, you need ways to establish trust among all these different communicating entities. We call it credential management. And another aspect that you have to pay attention to is you will have to be able to detect the cars that are abusing its communication capabilities to attack your system. To attack your system, including attacking your cloud, attacking other cars, sending bogus messages to you, trying to get you confused, trying to blame other people or causing bad things to you, so that you're going to do things to block those sites, for example. There are a long list of ways that you can simply do just by tweaking the input to a car and causing it to send bogus messages. We looked into it. We were able to discover such a long list of things. So, now I'm going to use a very important area as an example to give you a little bit more detail. And so, because of the time limit, I'm not going to be able to dive into very detailed technically, but just to show you malware dependency. So you want to, as we said, every single communication channel you have with the outside, not just the wireless, physical access, your USB connections, can bring malware into the vehicle, right? So, first of all, once the malware gets on your car, it can really, really do a lot of things. In theory, it could do everything you have heard about that people can do with physical access to the car, and even more. So some of the things. Okay, let's start with the in-vehicle infotainment, because that tends to be the most vulnerable part of your car. The very first thing it can do is it can consume CPU and storage, and exhaust your CPU and storage, and bring down your car's computation platform, or make it ultra slow. But you don't even know what's going on. You don't even know whether that's caused by a malware. You may just think, hey, I got too many junk stuff on there, right? To deleting, modifying data on your car. Most of the memory, most of the storage space on your car, they're not encrypted. Even if they're encrypted, I can delete them. I can randomly delete things, and you know what that's going to cause. To more severe things, I can now abuse vehicle features. Imagine I got malware still just on your IVI system, not even to the mission critical systems yet, just the IVI system. I can arbitrarily turn on and off your radio. You're driving, right? You're enjoying, boom, your radio is on. And your volume is turned up and down randomly. You want to turn it off? No way, I'm going to lock it. And that's very easily done. That has been done. Everything I see here are not imaginary. They have been done. They're documented. Disrupt normal operation. As I said, you can lock almost every single function on your car. Ransom. That's a very, very interesting thing. Ransom malware does the following. It disables some of your features and asks you, if you pay me X dollars, I'll reactivate it. On the computer, it tricked a lot of people. That's one of the fastest growing malware in the world. However, people can still deal with it, right? If you know that's a ransom, you're not going to pay it. You're just going to get rid of the malware. If you can't do it, you send your computer to somebody who can, right? Now, imagine your car gets that. You don't have a whole lot of good choices. The malware locked your door, locked your radio, says, okay, you can't turn it on. Pay me $10, I'll unlock it. What's your choice? You don't pay me $10, you're going to send the car to the repair shop. That's going to cost you more than $10. Right? So you really don't have a whole lot of choices. That means you really don't want this type of malware to get on your car. You can't handle it properly when it gets on your car. So what that means to us is that when we were designing our anti-malware solutions for cars, we pay special attention to those type of things. Right? They have higher priority. They may have as high a priority in the enterprise domain, but they do in the car domain. Disable vehicle safety functions, for example, if the malware started to spread into your vehicles, and you can imagine what can be done, even if it does not. A typical structure of the car is the IVI system is very exposed, very vulnerable, but the inner cars are higher security. The connectivity between them are guarded properly, guarded very, very secretly, and with those hard-coded messages, for example. Right? That's a very typical thing. Okay, imagine what this malware can do without even getting into the rest of the car. It knows what messages you can accept. The least it can do very easily is to create the same type of messages and send a whole lot of it into the car. That will easily flood your internal networks and bring down the functions of your communications. And we experimented with that. We know that can be done, and that can be done not very difficult.